Hello, Year 10. This video is all about, I'm looking at acceleration, velocity, time graphs. As I always do, though, what I'd like to do is give you a little starter to get you going. So you have done distance time graphs. And here I've got, you haven't got the units bizarrely not on, distance in meters, and I've then got the time in seconds. And what I've got here is a distance time graph. And what I'd like you to do, it's like I've said before, is pause the video. And then what I'd like you to do is have a go. I'm trying to think what, I know I haven't got an A here, but what F, D, C, E mean. Is it object accelerating? Is it a constant speed, or is it stationary? So pause the video and have a quick guess. I'll work it out. Welcome back. Now you've gone through and you wrote down in your book, or back your book somewhere, the answer to here. So this one, you should have C is going to be straightforward, a constant speed. And then at D, it's going to be stopped. It's not going anywhere at all. And E, you have got acceleration. And at F, you've got deceleration. And at G, you've got constant speed again. But I would like you to notice, using a different color pen, the fact this constant speed is going to be big and this one is not going to be so big. And the whole reason behind that is because here is going to be steeper than that one there. Okay, hope you got them all correct. I'm sure you did. Now, to go with that, what we're doing is, this video is all about acceleration, velocity, time graph. I'm probably only deal with this part first in this video here, and then velocity time we're done in a separate video. So I would like you to be able to explain the difference between velocity and speed, and then calculate acceleration using an equation. Now you'll find all this is in your book at page 152 under chapter 5b, and it's all under title obviously acceleration. So here you go, two wonderful year 10 students, and you can decide who they look like. Yeah, it has to be Harry, this one anyway. Anyway, year 10 students have now recently passed the driving test and now driving a car. Now they're going down a motorway. So you can have this one here, which is going to be, looks like Harry, where you want to be, going along this speed here, and I'm going to say, we're going to do at 30 meters per second. This person here, nice young lady, is traveling this way here, and she's also, let's say, she's doing 30 meters per second. So they're approaching each other at the same speed. Now this is a common thing going through. Remember, speed is going to be our good old scalar quantity. So basically they can have a magnitude, how fast they're going. But what I can do then is bring in the idea of velocity, and we mentioned this in our last video, which is going to be the vector quantity, which means it has got size and direction. So the size I've already mentioned is 30 meters per second, but now what I'm doing is I've got to give a direction. So no matter which way you do it, I can say this is going to be positive and that's going to be negative. So I mean by that is going to this way is going to be positive, and going the opposite direction is going to be negative. So therefore, to show a direction, I can have a positive and negative, or I could say this one is going to the right and this one's going to the left. Sometimes we use negative signs, which makes it interesting then, because won't I have a approach speed? Therefore, the difference between these two numbers end up being 60 meters per second. Therefore, they approach each other at a speed of 60 meters per second. And that's where the vector quantity comes in to allow us to work that out. Hope you're happy with that. Now, we were doing some practical work in ticker timers, but unfortunately we're not in at the moment, so we couldn't do it. Not to worry. Therefore, what is acceleration? Well, taking the lovely lady, gosh, the very strange purple wig she's got on, but anyway, here she goes, purpley blue, I don't know where her colour is. Anyway, here she's going on, and I said she was travelling in this direction over here. Now, if she, say, example, started off where she was stationary, what I can do is a little timeline like this, where I'm saying here's time 0, 1 second, 2 seconds, and 3 seconds. So let's say at 0, she's traveling at 0 meters per second. At 1 second, she's traveling at 3 meters per second. At 2 seconds, she's going to be 6 meters per second. And at 3 seconds, then she's going to be traveling at 9 meters per second. What I mean by that is she's obviously accelerating because you're getting faster. But isn't her speed changing? And we say this is a delta V, which is a change in speed, is going to be 3 meters per second. And that's going to be every second. Does that make sense? Therefore, it goes up by steps of 3. Therefore, what it means is she has got a acceleration of 3 meters per second. In other words, the acceleration is 3 meters per second squared. And that's where this weird unit comes from. In other words, her acceleration is going up by 3 meters per second every single second. If it's going to be 6 meters per second squared, it will go 0, 6, 12, 18. Therefore, what it does, it gives us an equation that acceleration equals delta V over t. What I mean by that, that is the change in time. Sorry, change in velocity. Therefore, that is measured in meters per second, and this is measured in seconds, which gives the weird units of acceleration going to be 3 meters per second squared. And this is a formula, I'm afraid you're going to have to learn this one. It's not given to you in the horrible, nasty exams. So I'll get that written into your book, but you also find it in your book under page 152. So, rubbing this out of the way to create a bit more space for me, this is a calculation showing how you do it. You've got a car accelerates from 2 meters per second to 28 meters per second in 6 seconds. What is the acceleration? So what you do is you write down your formula, and remember we're using formula working answer units, and there's the formula. So then to work out your change in velocity, well, the change of velocity is going to be 28 minus 2, because that's going to be your final speed and that's going to be your initial speed. Then it does it in 6 seconds. And we can all do this now. What you can do then is you take your 28 minus your 2, and then you get your 26 over 6. Okay, 26 over 6, we all know then equals 4 and 2, 6, which is exactly the same as 4 as a third, or you can write down as that as 4.3 meters per second squared. So all you do is take change of velocity, 28 minus 2, divided by the time taken, 26 over 6, then gives us 4.3 meters per second squared. Just shown the formula, I've shown my working, I've shown my answer, and I've also got the units as well. Okay, now what I'm going to do is, I think that's going on, is I'm going to attach this post as well. Oh dear, but actually it works. It's going to be, might even down here actually, there you go, here, is going to be this worksheet here. And what this worksheet does, they start off with 1 chili. Yes, it's a good old chili game. 1 chili are easy ones, going hard down to you got 3 chilies. I think I might have a marker scheme with the answer well somewhere. Anyway, what I'd like you to do is I'd like you to go through them. And what you can do is you can actually work out the acceleration each time. They do get slightly harder going all the way down to this table at the bottom here. If you're feeling confident, go in probably about here. If you want some easier practice first, start the ones just over here. Okay. Now, the last thing to mention is if you ever end up with acceleration like this, he gets hold of his pen. I got a nice red one, checking here, of minus 3 meters per second squared. That is when an object is slowing down. For example, at 0 seconds, I could be doing, say, 3 meters per second. Therefore, 1 second later, I can only doing 3 meters per second, and therefore 2 seconds later, I must be going at 0 meters per second. And that's what the negative sign means, is you're slowing down. Okay, there's the worksheet we attached here. I'd like to have a go of working out acceleration.